Hello and welcome to the 20th lecture for AC 1002. This lecture is going to look at cladding. So from previous lectures we looked at the building envelope from a technical point of view, from how it handles heat loss or water penetration or the control of vapor within the building, and all the various layers that were required to do that. The thing that we missed off from those lectures was the thing that gives the building its appearance. So this is the outward face of the building we're going to look at today, which for the purposes of this we'll call it cladding, because it's a timber frame that's doing all the structural load. The material that we see on the outside is really something that's added to it. It doesn't hold any structural value. So I'm going to call it cladding. You might hear it called an outer leaf if it's brickwork, but it's all the same kind of stuff. We'll come on to that. So what is cladding? Effectively, it's anything that's placed outside the main structure which doesn't contribute to the load-bearing capacities or capabilities. So if it's brickwork, it's carrying its own weight, but not carrying the weight of the roof. If it's timber cladding, then it's fixed back to the face, but it's not doing anything structurally. So it could be fixed back to the main structure in timber cladding or metal panels, or it can be freestanding and tied to the main structure like brickwork and blockwork. And we'll come on to tying later on. It can be solid, so brickwork and blockwork are quite solid, masonry is quite solid. It could be slatted, so timber's usually got little gaps between it for ventilation. It can be quite open, so we can use louvers, or perforated, or it can be a combination of these things. So what do we have cladding for? Why do we need it? Initially, it needs to act as a rain screen. So it's the first layer of protection against the elements. And by rain screen, we mean something that stops the snow and the rain hitting the construction inside. It's probably not 100% weather tight, but it's enough to be able to prevent the kind of the driving rain from hitting it. It also needs to protect the breather membrane behind, and in the breather membrane lecture I touched upon the fact that if it's left exposed for any extended period of time, the UV light, the ultraviolet light within sunlight can degrade it, because it's made of plastic, and a lot of plastics will degrade in UV light. So we need something there that provides shade and cover for the breather membrane. The cladding is also important from an aesthetic point of view, and that's probably the primary thing that you'll think about for what your choice of cladding would be. What's it going to look like on the outside of a building? So there's a couple of different types of cladding, and I think you could probably split them into three different types for the purposes of this module. Timber cladding, so we can use, could be placed vertically or horizontally. We can use durable timbers without treating them, or we can use softwood or less durable timbers. We can paint it, we can stain it, so it's quite versatile. Masonry cladding or brick cladding, we can use natural stone, concrete block, we can render things, we can have brick on the outside, so again it's very versatile in its appearance. And the last example there is metal sheet or profile sheeting. So this could be something like a pre-manufactured panel system with insulation bonded to the back of an aluminium sheet, or it could be aluminium sheets that are formed into standing seam, or it could be lead, or it could be metal tiles. So there's a lot of variety in metal cladding. Now we're not going to go into metal cladding because it's quite a complicated subject, but it's worth looking at the metal cladding that was used in Grenfell Tower to see how something that can be specified for use maybe doesn't hold up in practice. So there's a lot of questions around metal sheet cladding, so we're not going to cover that within this module. So if we look first at timber cladding, there's a few considerations. We need to figure out how we're going to put this stuff on the wall. If we have, if we split it between vertical and horizontal cladding, vertical cladding needs, or all cladding will need some support behind it. And usually we do that by having a series of battens that form a void behind the cladding. So those battens would be fixed onto the sheathing and screwed back into the studs behind, and they would kind of form a space, but also a fixing for cladding. So if we have vertical cladding, we need battens which support it horizontally so that we can fix each board to it, and battens that run vertically to make sure that there's a space. So there's an additional cost and thickness of the wall for vertical cladding. We need to think about the choice of timber. It's going to have a big difference on a bigger impact on the appearance of the wall. Not only the colour of the timber and the grain of the timber, but also how it's fixed. And I'll show you some examples later on, but I've got a note there saying oak requires pre-drilled drilled holes and washers, whereas larch does not, and that's to do with the strength of the timber. So there's an image coming up. Different timbers have different durabilities. So a durable timber we can put on the wall, and it's going to not degrade under sunlight. It's not going to be tremendously affected by fungal attacks. It's maybe going to be resistant to insects infestation. So it's quite a durable timber, and we can put that on the wall without having to paint it or stain it or do any other treatment to it. And usually that durable timber will turn grey over time. So as it gets denatured by the sun, the colour will bleach out of it and it'll become a kind of silvery grey colour. Whereas non-durable timbers usually need a paint or a stain or some other coating, and that needs an ongoing maintenance regime. So if you're using a non-durable timber that's got a stain to it, then every 5 years you're going to have to redo that. So that's a consideration at the start. So if we look at an example of a durable timber cladding, this is a horizontal timber cladding. It's a Western red cedar, which is a kind of orangey brown colour. You can see there's quite a lot of knots in it. And the way that this timber has been put onto the wall is there will be vertical battens behind that, because you've got to fix every board in the same place. And the profile of the timber cladding is quite important. The overwhelming effect of this timber cladding is to give you straight horizontal lines, and these are produced by having a profile which gives a slight shadow from one board to the next. So as architects and designers, you can make choices about the shape of the timber boards as well as the materials to give your designs a particular effect. So if we look at that horizontal cladding, here's a detail here, and I'll get my mouse pencil-y thing out again, see if I can figure out how to draw on top of this. We've got our boards, and they kind of overlap each other and make a little space for the next board to come in, and that forms a shadow line between them. So this is generally called shiplap boards, and each of these boards would be fitted back to a batten that runs behind. So a batten is just a smaller version of a timber stud. It's a small piece of timber, usually treated to stop it being eaten by insects or attacked by fungus. And these things would be nailed on. Usually with shiplap you can do one nail and then allow the fixing to cover over it so we don't see anything on the face. And the battens would then be fixed back into the studs behind there, so they'll be nice and secure. And this gap that comes up the side allows for any moisture that's within that space to run down the gap behind it. And because we've got vertical battens, there's nothing to stop it going up. But also we get some air movement coming up the back of it to help dry out the board. So ventilation behind timber cladding is very important. And with horizontal timber cladding, there's a number of different profiles we can use, and each will give you a different kind of architectural effect. The one in the photograph that we saw was this the sawn element here. So one board is sawn over the other, and we get a sharp shadow underneath underneath each board. So at the bottom of the board, you would see a shadow onto the board below. But you can use square boards. You can overlap square boards down at the bottom here, or you can get highly profiled boards which fit into each other in quite a distinct way, and like that one there. And usually with this one here, you might look to put the nail through that point there, so the next board coming down would step over it and hide that nail. So you get a secret fixing if you use a more extensively profiled board. Earlier on when I mentioned that oak needs washers and pre-drilled holes, this is an example of an oak wall, and we can see all these fixings here. Now the reason that oak needs that is because the board is so strong that if we were just to nail through it, as it expands and contracts, so it's going to move in and out along its length and along its width and across its depth, that there's a possibility that these nails would actually start to pop out. So what we tend to do is, and I'll draw up at the top up here, is you would have your board. Wow, that's an awful drawing. Right, we would have our board like that. It's truly awful. And the screw would come through the board like this into the backing, and we would put a washer there and then the dome head of the screw. So the board could move about a little bit, and this little gap here would be enough to be able to take up that slack. But making the choice about this material means that you have to choose to have the fixings on display, and if that's an aesthetic choice you can live with and you can design it in, then great. The other thing about this image, which is quite interesting, is the windows here. So the size of the windows have been sized to work in with the cladding. So we can see that there are 4 boards for the height, and there's a vertical gap that lines through here. So the windows have been thought about at the same time as the cladding. So it's not a mistake. It's not just a CAD drawing that's been put together. So you need to consider what the outside appearance is and how the cladding is going to fit in to make sure that you can design your windows to be in keeping with the rest of the facade. Vertical cladding is a little bit different, and usually in Scotland we're talking about a variation of board-on-board cladding. So it's front boards and back boards. So we find that we've got a board here that we can see going upwards, and then behind that there'll be another board, and the same to the other side. And these boards will be nailed through. Don't think we can quite, yeah, there's a nail there and there's another one there. And because it's probably larch, this timber here, so it's got quite a rough surface, we don't see the fixings. The board isn't as strong as an oak board, so it's not going to pull those screws out. It's not going to move about as much, or if it is, it's going to be held by the screws. So the board-on-board cladding is quite a common way to do timber cladding, vertical timber cladding. And we can see there that we've got kind of what I described. We've got the front board at that point, and then we've got a back board running behind it, and there's an overlap there of about 20 millimeters, something like that. But we still need to have drainage down the back of the boards, and we still need to get air coming up the ventilation void to make sure that we can carry that moisture away. But if we only had these horizontal battens, then if we were to look down the face of the wall, wow, I'm getting really bad drawing on this mouse. If we only had battens running horizontally, if we're looking at this in section, I need to learn how to use this properly, and the board's coming down here, then this is blocked, so you would get water sitting on top of these battens. So what we do is we put an additional layer of battens at the back here, so that there's a clear space behind those front battens to get moisture down. The other thing is that we usually we usually cut the top edge of the batten to make sure that it throws water away from the face of the wall. So we would take a piece of timber, and from the top of it we would cut that bit off so that any moisture coming down there can actually roll away, right? And we'll see an example of that in a detail. So here's a section detail through a window, or possibly a door actually, and we can see we've got our vertical cladding boards there. We've got our horizontal battens at that point, and then we've got our vertical counter battens. So we've got a nice clear space to be able to get some ventilation up into that spot there. And any moisture that's sitting on top of this batten here is actually going to start to fall down backwards. So we need a little space down at the bottom, so about 15 millimeters, and that's to allow some airflow up into that void behind. Down at the bottom of the opening, we've got some other pieces of timber here which are forming a step and getting it out, making a flashing. So there's a piece of metal effectively that sits down here, and that means that any water down here is actually going to hit that and drain out and drip clear. So if we look in plan, this element here is our horizontal batten because we're not seeing it in section. So this is cutting through, and this is a section, and this is a plan. Got to learn to draw with a mouse. So we see that, then that's our counter batten. So this bit here is our airspace running down. I could have saved myself all the trouble if I'd remembered to put that slide in. And these details have been developed up over many years of practice, but they all rely on air to be able to dry out the timber, and battens to be able to create spaces in these. So if you look at this detail, which I think is from a book called Timber Cladding in Scotland, we've got the same kind of details round about the head. We've got battens that are cut backwards to a fall. So they all do the same sort of thing. There's no set size for doing all this work to make flashings, and realistically, if you wanted these elements to poke out a little bit more to give you more emphasis, you could do that as long as you could actually get a piece of timber to do it. It would do the same thing. What we've got here is an elevation view as well, so we can see the element that was the metal flashing sitting at the top there is now sitting over the top of the window, and it's got a little folded end to it. So and these are the boards that are sitting over the top of it. So if we move on to masonry cladding, timber frames can have many different types of masonry cladding. We can use almost any masonry material, but most commonly it's brick or blockwork or stonework. And in contrast to timber cladding, it's not relying on the frame for support. It's supported off the foundation. It's got its own separate leaf of masonry. If we are using bricks, we have to understand that bricks are a set size. So, and there is a slide at the end, so I don't have to use my mouse to draw. They're a set size, so usually we would design our building to suit those set sizes so we don't get any funny cuts. And bricks and other stones are available in lots of different colours and finishes. If we've got uniform bricks, we can see the laying patterns. Masonry can discolour. The choice of mortar joint can affect the appearance and durability of construction. So there's lots of different characteristics that you can choose at the design stage, which will make a difference to how your building appears. For most masonry cladding, because we're building a separate leaf outside, we need to have some sort of ventilation within the construction. And usually those are things that poke through from one layer to the next, and they're going to be visible on the face. We're going to be able to see them. So here's a kind of typical example. I think I stole it from the Kingspan website, so I should probably have a reference on that. So we've got our timber studs sitting here, and we have our sheathing board there, and this stuff here is our breather membrane. We've got insulation sitting between, and I can just about see the shiny face of a vapor barrier, and then we've got plasterboard inside. And there is a gap down the back of this. There's a cavity or a void before the brick leaf gets put in. There's a couple of things to note on this. I mean, the bricks are quite regular sized. We'd be looking for a cavity of about minimum 50 millimeters at this point, and but we need to tie the wall, the outside leaf of the wall, the cladding, back into the timber frame so that they don't fall away from each other. The brick wall is actually quite slender. It's only about 100 millimeters wide. So it actually needs to be supported back off the timber frame. And this element down here is a wall tie. And usually what wall ties are, they are either a helical screw that's fixed back into the sheathing and the stud behind. So that will actually go right the way back into here and probably fixed into the structure behind. That's the stud away up here. And in this case, it's got insulation in the cavity, and this round thing is a retaining clip. And what would happen is this helical element here would then be bedded into a mortar joint, and there would be another brick then laid over the top of that. And as those things are put in place and we raise the brickwork up by different levels, we get more and more of these wall ties in there, and it allows your two walls, your timber frame wall and your brick wall or your brick cladding to work together as a system. And the number of these wall ties and their frequency relies or is dependent on how exposed the building is. So if it's a building in a very exposed location, we'd have more wall ties. If it's not so exposed, we would have less. And that's to do with wind hitting the face of the building. So if we're looking at brick, we're going to cover coordinating sizes for brickwork in future modules. So we don't need to know too much about it just now, but it's worth having a think that the size of bricks is related to the length of them. So we can say that the width of 2 bricks plus a standard 10 millimeter mortar joint equals the length of a brick on its side. And this is called coordinating sizes. So you can lay out a whole building based on that fact. Mortar joints are usually 10 millimeters wide, and that's a kind of standard size. And a brick is a set size, so we get 102.5 across the width, and the length is 215. So 102.5 plus 102.5 plus 10 equals 215. So we mentioned that we've got a ventilation gap at the back of timber cladding, and we need that for to stop moisture getting into the construction, but we need it to ventilate the construction. So in timber cladding, we need to avoid rot or insect attack or fungal attack. So if we have ventilation within there, the timber is allowed to dry out. The air is going to be carrying away moisture, so it's never going to get wet enough for mold or fungus to grow. So we need a free draining cavity at the back of timber cladding. The same for brick cladding, but it's not really to do with fungal attack. It's to make sure that the moisture can't get into the timber kit behind it. So we'd normally have a 50 millimeter cavity, but it can be much wider. And the cavity should be ventilated top and bottom of the wall. So you would install small weep vents at the bottom and at the top, and that would allow a certain amount of air as the wind blows against the building to be able to push its way into that cavity. But because we've got a cavity, there are some issues with fire within a cavity. And if you imagine a situation where you have a house that has a number of different rooms at ground floor level and they're clad with brickwork, if there's a fire in one of the downstairs rooms, it's possible for that fire to then break the kind of bond round the window, and if there was nothing to stop it, it would get into that cavity. The cavity, because it's a vertical space, would act like a chimney and would carry fire and smoke upwards to another room, but it would be unseen, so there's no fire alarms or smoke detectors within that space. And we've got to divide up cavities to make sure that they don't act as passages for fire to move from one space to the next. So what we'd normally do is install a cavity fire barrier. And we put them around windows and doors, and it's a proprietary closer, so it's a bought product, and sometimes that can be a fire barrier and a DPC, so if it's waterproof as well. We'd need to divide walls up, so we'd want to divide them up along their length. So we'd have vertical fire barriers at corners, party walls, so that's where two houses share the same outside cladding, and in some other locations depending on the use of the building. If we've got a building that's more than 1 story high, then we would have horizontal barriers so that we could divide up the cavity by its height. And we'd probably have them at intermediate floors and at the wall head. And what a cavity barrier is it's usually a solid bar or a flexible bar of non-combustible material. So for a timber frame, timber cladding, sorry, it would be these products in bags. For brickwork, it would be these rigid mineral wool sort of battens. Mineral wool doesn't burn because effectively it's stone. The bags I'll come on to in a second. They work in an interesting way, but the rigid ones, effectively what you're doing is you're sticking them back onto the timber frame, and they would seal hard up against the brickwork. Oh, red's the wrong colour to do that in. They would seal hard up against the brickwork at this point, so that if there was any fire within this side of the cavity, it couldn't pass by that and get to the other side, especially if this was house number 1 and this was house number 2. So we need to divide up at that point, and this material is usually fireproof. The plastic wrap around about it is really just there for handling. If there was a fire, it would burn away, but the material would still be there. For timber, it's important to be able to keep the airflow behind the timber going all the time. So we can't always just block off the cavity. So we use an intumescent material, which expands under fire. So it's something that when it gets hot and it gets charred, it reacts with the heat, expands out, becomes an impenetrable fireproof foam. So we can get either intumescent materials, which is this cavity barrier here, and under fire it's going to expand out, or we can use the bags from 2 slides ago, which are compressed mineral wool that when they burn under a fire, the bag gets removed and the mineral wool expands out, and there's some intumescent properties in that as well. So in conclusion, just below the 30 minutes here, sorry about this one, it's a long one. The external skin of a building, the cladding, acts as a rain screen to prevent the worst of the weather reaching the construction layers behind. So it's stopping driving rain and snow. Regardless of whether this is masonry or timber, there needs to be some sort of cavity behind it to provide ventilation and a means of getting any water that gets into that space out. Timber cladding usually is fixed back to the frame, so it relies on the frame for support, whereas masonry has its own separate leaf for the foundation. So there's a few aspects you need to take from this lecture. First is that cladding protects the breather membrane from UV damage, that masonry is tied to the timber frame but not supported directly by it, that ventilation and drainage are handled by a cavity behind the cladding, so we have a space, and that the cavity needs to be divided horizontally and vertically to prevent the spread of fire. Okay, thank you very much for listening, and I think there's one more lecture, so there's 21 in this series, so bear with me for one more. Thank you.